Good morning or afternoon, gentlemen, depending on the time that you are seeing this lecture. Today, the plan is I'm going to cover an open versus closed system, the law of conservation of mass, and then for homework, you're going to watch two EdPuzzles, one over open versus closed, and then one over the law of conservation, and then you're actually going to complete a FlipGrid explaining an open versus closed system. I'll explain more of that at the end. However, let's get into our lecture. So, is what I see chemistry? Physical properties of what I start with. So you always start with the physical, you do not start with the chemical properties. So the physical properties are states of matter, change, so like solid, liquid, gas, a color, an odor. Really think of your five senses because physical is something you can see with your own eye, or you can smell it, you could touch it. So an example of that is like, what did I see happen? So if I see a color, I see light coming out, I see gas released, precipitates, which if you think of that with the precipitate, think about our last lecture when I showed you with the iodine reaction, when we added it into that water and then it turned yellow. So that only happens when it becomes solid, and then we had a temp change potentially. Where new chemical bonds formed. So different solid, liquid, or gas is now present. So these are all the physical properties that you can see because you can see a change of matter. So there's a couple examples right there. And again, we're going to practice this in lecture this week. However, if you've already had me for lecture this week, then we already practiced it and you really kind of have a better sense of this. So sometimes it can be hard to tell because state changes are physical changes. So if you see bubbles from a gas, is it the same substance in a gaseous form or is it a new gas? That's really a question you want to ask because if I put water on a stovetop and I boil it and it evaporates, it becomes a gas and I can say, hey, that's water. But if I were mixing two things and a gas was released, then it's completely different because it's not a physical change to that. You're actually getting something completely new. However, you're going from state changes. New chemical bonds formed, and then all atoms are accounted for. So state changes can be when new chemical bonds form or a change like if you do precipitates. But no matter what, when we go through our changes, all atoms are accounted for. We don't lose atoms necessarily, and I'll get into this more when we talk about law of conservation of mass. However, when I have a reaction, I'm not going to lose what I started with. I'm still going to have it, even if like it goes through a state change, I still have all those atoms from this original state change. So law of conservation of mass really shows, hey, all the atoms are accounted for. You don't destroy them. Matter is neither created nor destroyed in one reaction. All right, so what you're going to do is you're going to learn about an open or closed system. There's a third system called an isolated system. However, we don't really talk about it in this class, and so your focus will be closed system and an open system. So what you're going to do is you're going to complete the EdPuzzle to really understand this, and the information that you get from the EdPuzzle is what you're using for your FlipGrid. So I recommend going and pausing this video. So if I escaped from here, oh, excuse me, and I go to EdPuzzle, you want to watch this one. The isolated system is not included. However, this was the title that I did have on it. So you're going to focus on open and closed, and I did stop the video, and I do have a series of questions, but make sure you take notes since this is a part of your FlipGrid. All right, and then you will be watching another EdPuzzle here shortly. Our next thing is our law of conservation of mass, and I said I'd kind of talk about this. So the total number of atoms, which is your mass, if you think about it, before the reaction is the same as after the reaction. So for example, conservation of mass can say, I have a calcium chloride solution in this little test tube, and I have a sodium sulfate solution right here. If I dipped, like if I had it closed, and I dipped in my test tube, and I had a reaction happen, and my test tube's empty, and I zeroed out all the glassware, and I started with this much, I should, no matter what, end up with the same amount. So your mass of reactants, which is your start of the solution, equals your mass of your products. Now, I do have an EdPuzzle for you to watch, which you probably saw when I went over. You're going to watch this one right here. Again, I would take a lot of notes, but it really shows you kind of the math side of it, and we're going to practice this in lab again, so you'll get a chance to really try it out. So this was a really short lecture because you are completing EdPuzzles, and I don't have any homework assignments with it. However, like traditional homework, I would like you to go onto FlipGrid and you are going to draw your own diagrams of an open versus closed system. You're going to record yourself talking about them and explain what happens in each one. So I recommend using arrows, much like the images that I showed you or what he kind of covers in that video. So you can say, an open system is this type of container, and this is how energy moves, and this is what happens. I don't need it to be super long. You have about 1:30 recording time. It shouldn't take that long. But if you go to the canvas, it's under your FlipGrid, and it's right here. I do have a draw a diagram and then explain the key differences. You'll record a response, and you should be good to go. Other than that, it was a very short lecture, I know, but that's all I have for you. If you have any questions, please email me, but that's all. And make sure you complete your vaping worksheet and questions. We will be discussing that next week. All right.